Welcome to part 2. Since I was rudely cut off, we're in my home studio and everyone's gone. So it's just you and I and a terrible teenager upstairs, but she's out of sight right now. Let's go back to general concept of power as we generally use it. Science defines power as the energy consumed, lost, or generated in a given amount of time. It has the general formula of power equals energy over time, which has the units joule per second, which we unfortunately have nicknamed the watt, and herein lies a significant problem. In other words, power is the rate of energy flow, but by the fact that we've nicknamed it a watt leads most people to think a watt is a total. Like, how many watts of light are there? It's not a total, it's a flow rate. So if you understand liters per second, dollars per hour, energy flow is joules per second. It's the same thing. Now, every subject has its own version of power. There are power formulas for everything. In electricity, we're going to see that power is voltage times current. Now, I can prove to you that power as energy over time is in fact voltage times current. And many of you will be able to handle that, but it will not be done until grade 11 or 12 physics. So if you can handle it, it shows your brains are 2 years ahead of the crowd. So feel free to ask me how to demonstrate that. Here's the two formulas you're going to need to work with in this unit. Power is energy over time, which is the most general case, and power is equal to voltage times current, which is the specific case for electricity. These are the only two formulas. It will seem like there's a ton of other stuff hitting you, but this is really the key here. Now, how do we understand this?
I ate 2 cookies. This is a quantity. For electricity, it is the coulomb. 2 cookies is like 2 coulombs. I eat 10 cookies a second. This is a quantity rate. Quantity per second. 10 cookies per second. For electricity, this is a coulomb per second and is nicknamed the amp. So I could be a 10 amp cookie monster. 10 cookies per second. Now, no, get out of my throat. Okay.
But what kind of cookies are they? So try to imagine talking to a person on a diet.
What did you eat?
10 cookies. 10 cookies? 10 cookies a second for 8 hours. Were they rice cakes?
Lard.
So if you don't know the energy in each cookie, counting the rate you're eating cookies doesn't really work. So do you understand the difference? You can tell me how many cookies you ate in a specific amount of time, specifically a second. Or you better tell me the calories in those cookies you were eating per second. Okay? So joules per second gives us the best idea of the energy flowing down the pipe, or the power. So what you need to do when you see the word watt is it's really joules per second. If you're not metric, it would be calories per day. And the minute you see watt, you scribble it out and write J over S, joules per second. And then you will have no problem whatsoever. Now, I don't necessarily mean you have to scribble it on the page and write J over S, but in your head, you turn it to a rate. If you don't, you will be trapped in the adult world thinking that a watt is a total. And $10 per hour is not a total. So now let's take you to a Jedi level. Remember how I want you to be natural at science. I want you to be able to shoot from the hip. So we need to put this in perspective. Power is equal to energy over time. How do you know if 1 watt is a lot of power or not? You just work with numbers till you get comfy with it. If you have a 60-watt light bulb, would you lick it? The answer is yes, you could, but it might be uncomfortable. Your hair dryer is 1800 watts. Stick it in your mouth and turn it on. Metaphorically, not for real. Is 1800 watts of heat, 1800 joules per second, a lot of heat or not? So the best way to put this in perspective so you have this figure in your head is let's look at what a human being's energy consumption is. In a single day, you eat about 2,500 calories. In metric, this is 10 million joules. Girls, no, you're not, no, I'm eating 10 million joules a day. No, it's still 2,500 calories, right? Joules is like measuring the distance to Toronto in centimeters. A very tiny amount. A single day has 86,400 seconds. So let's calculate your power burn. How much energy are you going through every single second if you eat 10 million in a day? And this is a really good back of the pocket kind of figure, so you have a rough idea what these numbers should read like. Right? You guys know now if I said, let's walk 100 kilometers today, you're old enough to go, whoa, that's quite, that's a lot. If I say to you, hey, my car can go 300 kilometers an hour, you're going to go, no, it can't. But an 8-year-old might go, oh, really? So, let's take you. 10 million joules and 86,400 seconds. Keep them little letters. I know you want to drop them. This is science, not math. Do not drop the J or the S. Keep them. Mega means millions. And a million means 10 to the power of 6. What's with the little quiffly-quaffly thing here? That's approximately. It means like when you wave your hand and someone says, how much do you owe them? And you go, $20, and you wave your hand in the air. That's the wiggle wave. I'll show you it in person. I rounded 86,400 seconds to 100,000. People are like, oh, you can't do that. Well, I just did. So what does this come out to? This comes out to about 100 joules a second, which is 100 watts. So you are, in fact, as bright as a 100-watt light bulb. Now, I know a lot of you just don't want to round. And rounding is your friend. Comprehension is best when you round. So, how much did I bugger this up? Well, let's carry it out exactly on a calculator. I won't round. I'll leave 86,400 seconds, and I get 115.74 watts instead of 100. Ooh! Big deal of difference. Rounding is acceptable on my test. If you have other teachers later that don't like rounding, they're being too nerdy as far as I'm concerned, but you do as they instruct. Okay? Now, I could have done this in my head actually quite easily as well, because you could actually take 100 and divide it by 86, and I can show you in person how easy it is to do the math in your head. Now, see the slides gone blue? Feel free to skip. This is just for those of you that are curious. Why I hate people who want to carry out every calculation to multiple decimal places, thinking that I screwed this up by taking 86,400 and rounding it to 100,000. Now, if I divide those two numbers, this number is 86.4% of the other one, which literally means my rounding set the answer off by 15%. I mean, you can see it here. There's the actual answer. There's the real one. If you got 100 on a test out of 115, that's roughly a 15% error. Okay? But take a look at the range of megajoules you eat every day. From the age of 1, you start at 4 megajoules and you peak at 14. So throughout the high school years, like this, your calorie intake goes from 10 to 14 megajoules a day. That's a 30% change. So my rounding of the number of seconds in a day is half an error compared to not dealing with the fact that the 10 megajoules a day is an average for an entire human lifetime, and yet in your teen years it swings through these values. And this is what it is if you adjust for your weight. If you look at different weights of people, their intake goes from 3 to 15 megajoules a day. So this nonsense about, oh, I can't round, I'm screwing up the number. No. The energy value is already so approximate. Rounding the seconds per day to 100,000, it's more important for your understanding, not to bean count decimal places and not know what it is you've learned. Okay? So that's why learning to round is important. And the other thing is you do not put decimal places if they don't belong. Okay? Considering the range of numbers that this could change on, these decimals here are an illusion. All right? This is much closer to the truth than this is. And the trouble is, this, you'd go, he only meant kind of 100. Ooh, this guy's got it to 2 decimal places. This can lead you into thinking the number they got is more accurate than it really is. So, again, blue slide, don't pay attention to it for now, but keep this in your pocket for grade 11. Now, let's look at it a different way. No Cookie Monster. What have we learned so far? Quantity. We count a cup of electrons, or we count a coulomb of electrons. So I like to call coulombs cups. You don't ever really need to know how many cups of electrons are in the wall, because there's no limit to them. They will keep flowing for eternity. Only battery manufacturers have to deal with a fixed quantity. And even then, your cell phone doesn't say, I am down to 2.3 times 10 to the 3rd coulombs. It says I'm at 71%. Only the engineers that designed the device would know the coulombs in the battery. What we're interested in is what can flow through our wires. We want to know the flow rate. You're never going to ask, how much water is in the pipes to my house? Well, infinite. It won't stop flowing. So we want to know the current, the rate of flow. But unlike water, water has the same calories as it comes. So the rate of flow is all you need to know. But electricity, it's like, what if your water pipe instead, you could turn it so you were getting Gatorade down the pipe instead. You can actually change the energy inside the pipe. And that's not something you can do with water. Right? It's not like there's a valve to add sugar to the water. But with electrons, we can add energy. We can sweeten them with voltage. So now we get a flow rate, electrons per second. Or we can turn it into watts, which is joules per second, by including the fact that these electrons, they're spicy. They got a little bit of kick. I got some 9-volt electrons. They tingle the tongue for a long time. Okay, so we have quantity flow, energy flow. This takes 2 weeks to go through, but this slide, I'm very proud of, nails it in a very brief thing. So if you can keep it simple in your head, the rest is just gobbledygook. Okay? Now, we're going to take a pause here and come back, because I need to get a sip of water, and I don't like making my slides really, really, really long little videos. So where's my